This is Module 7, Part 2 of the Foundations of Programming with Python video series. In this part, I will continue talking about working with files, but we are going to be having a look at working with binary files. So far, we have always converted the data from whatever Python is using in memory to actually saving it as strings into a text file, which is very convenient if the data actually needs to be also readable for humans, or if it needs to be exchanged with other sources or destinations, so that you actually can do data interchange with external points. That is not always necessary for the data that you need to save for your own programs. Sometimes it is way easier to just dump the data as it is kind of sitting in memory and dump it into a file without going through the whole process of formatting it. To do that, Python offers the pickle module. Yes, it is exactly like pickling vegetables, and that is where the idea comes from. And what this module actually does, it takes what is sitting in memory for an object. Remember, everything that you're saving in Python into memory, everything that you're using, every data type, is in its core, at its base, an object. So the pickle module takes these objects and serializes all the information in there and returns that serialized version of an object, and you can save this to a file. And it doesn't matter how complex or how large that object is, pickle does it for you. So thinking about our CD inventory program that we have been writing, let's say you have an inventory of 100 CDs. Everything is in a 2D data construct. Just pickling it, you simply take your table and pickle it. You don't need to process any other than this. This is the basic idea of saving binary files. It also actually can have the side effect that the binary files might be smaller than the text files. Now, one important thing to remember and consider is saving information in binary format is not encrypting. That is two completely different concepts. So don't think that just because you pickled and saved your data binary, that it is safe. It is still reconstructable, it's still readable on the file system. It is not encrypted and made safe. So let's have a look at this pickling module. I've already pulled up the code here. So we have our data here as our strings, and then I'm creating a list out of this. And because we're not working with text files anymore, but with binary data, I'm not using the .txt extension. I'm just using the .dat, like data extension, for kind of implying this is a binary file. Using the pickling module, the pickle module, the code, the syntax looks different than what we have been doing with files so far. So we are going to be having actually to look at this documentation at the point when you're going to do your assignment. I'm not going to be introducing the documentation to you, so that is one of the next steps that I'm asking you to do here, looking that information up for yourself. And the syntax is different than using the regular file ones. The details you have to fill in yourself. And what we are doing with the open file is we indicate that we want to write with the W, and the B is for binary. We want to write binary. It's not regular text file. So also with write and append, we're saying that we're using binary. Now running this code, so we are saving it to file, and then it's reading it back from the file, and it's creating actually the list again. And if you're now looking into this .dat file, this is actually how it looks, or how it is being interpreted for ASCII code, so for a regular text code. And you see that there is some weird thing happening here. It's a sequence of zeros and ones that are being interpreted in this format as text. It is actually not text that is in here, so there is binary code in here that Python uses to describe the object that is actually being saved. And then the text within the object that we actually put in there is plainly readable, but with something in between here to actually say what are the different portions of that. In this case, it's a list. What are the different portions or the different values in the list? So this is saving information in binary format. So a few things going over this code to actually I want to point out. So here in line 8 we are using the import statement. We have seen import statements before. So for rehashing, the import keyword and signals to pull in code from an external Python module. So this means there is somewhere a pickle.py file that we're pulling in. And the same way as when we are creating classes and we use a class dot the function name, just by pulling this in we can use this name dot dump. So in that pickle.py file there is a function a dump that expects the data and a file object. We can access that by using this syntax. We already talked about the letter B here in those. And yes, we also mentioned that the syntax of actually accessing this file is a little bit different. With this, we are getting to the lab B, working with binary files. And we are going to be continuing with the code that we were using in lab A. We're going to be making a copy of that, and what we're going to be doing here is we are adding code to read program arguments to create distinct operational pathways in our program. We're using the pathway calc and IO. So calc as in short form for calculate, and IO. Within those distinct pathways, we are going to be using, in the IO pathway, we are going to be using the input function and output function against the screen. So first we're going to be outputting the results that are in the results file, and then we are ingesting the next numbers from the user and saving them into the numbers file. We are storing the files in binary format. In the calc way of using our program, we're going to be ingesting the numbers file, doing our calculations and populating the results file, also in binary format. With this, we are actually using the program parameters that we talked about and how to get them in module 3. So if you're no longer quite familiar with what we did there and how that worked, go back to module 3, have a look at that and implement that in this lab. Test your script and write down how this code works. And then think about for what this kind of a setup would be useful. With this, I'm concluding part 2 of module 7 of the Foundations of Programming with Python video series, and see you in the next part, where we're going to be looking into structured error handling.